Welcome to Zoom Lecture 2. This is going to be on difference, quotients, power rule, derivatives of sums, differences, products, and quotients. This chapter is going to be rather heavy, but it's probably the most important chapter for the semester because it gets us into the root of calculus, which is the derivative. In the last Zoom lecture, we talked about the algebraic definition of derivative known as the difference quotient. And let's review the difference quotient. If you look at the difference quotient, at first it seems to be somewhat intimidating. We have f of x plus h minus f of x all over h. Well, if you look at the picture here, you can see that f of x plus h just happens to be one of the y values. And f of x is the other y value. And if you subtract one of the y values from the other, you get this drop along the triangle, which is known as the rise. And then if you look at h is just, let me change colors here. H is just the horizontal displacement as you go from one x value to the other. One of the x values happens to be x. The other x value happens to be x plus h because you moved over a distance of h. And that's going to be the run. And if you'll recall from algebra, if you take the rise and divide by the run, also known as the change in y over the change in x, all you have there is the slope. So the derivative is, in essence, the slope between 2 points, in this case, on a parabola. Now, you may want to review the last problem in Zoom Lecture 1 before proceeding. Assuming that you have done so, let's go ahead and look at an application of the difference quotient in this problem here. We have a function which is f of x is equal to x squared plus 4x minus 7. The graph of this function would look somewhat like this one here. In other words, it would be a parabola, except the intercept on the y-axis would be at -7. But the picture would look very much like this one here. And the question is, or the task is, find the difference quotient for that given function. We'll go back to the formula for the difference quotient. You have to figure out what f of x plus h is, subtract from that f of x, and then divide by h. So what did they do here? Well, they started off simply by writing the difference quotient because that's going to be the recipe we're working with. And all they did was they went into the original equation, and at first, in order to find f of x plus h, they substitute x plus h in wherever you see x. So we have x plus h to the power of 2 plus 4 times x plus h minus 7. In other words, all of this here is f of x plus h. All they did was they went into the original equation here and they substituted in x plus h everywhere they have x. And of course, they subtracted the 7 because that's part of the function. Now, if you go back to the difference quotients formula, we have to subtract f of x. That's why they have the subtraction symbol here. And of course, f of x is x squared plus 4x minus 7. So here they just simply subtracted f of x. So if you look at the entire top line here is f of x plus h minus f of x. And of course, the formula says that we have to divide by h, which is the run, and this would give us the slope. So what did they do after that? Well, this is actually the hardest part of the difference quotient. It's the algebra. So what did they do? Well, if you take x plus h to the power of 2, that is x plus h times x plus h. Since this is x plus h to the power of 2, we will now FOIL this, which means we will multiply the two first terms together. That gives me the x squared here. And then we will do the outside term, which is going to be h times x. And then we will do the inside terms, which gives me another h times x. That's where this 2xh comes from. And then they multiply the last terms, h times h, and that gives us the h squared here. So if you're lost at this step, you may want to go back and do a Google search or check YouTube videos for the FOIL method, and you should find some great review videos there. So at this point, we have simplified x plus h to the power of 2, and then they just distributed the 4 across this x plus h, and that gave them 4x plus 4h here. Then they brought down to subtract 7, and then they just distributed this -1 here across this parentheses, giving us minus x squared minus 4x plus 7. Remember, a negative times negative is a positive. So at this point, all they have done is they have taken this entire numerator and they have simplified it, meaning they have cleared out all of the parentheses to give us this numerator here. And of course, don't forget, we always divide by h. The good thing about this is we have a positive x squared here, but we have a negative x squared here, so they will cancel out. We have a positive 4x, we have a negative 4x, and we have a -7 and a +7. So once we clear out all of the noise, we are actually left with 2xh plus h squared plus 4h. And then we simply divide by h. Since we have 3 terms here in the numerator, this is essentially 3 fractions. In other words, we have 2xh over h plus h squared over h plus 4h over h. So what would that look like? So let's see, we have 2xh over h plus h squared over h plus 4h over h. Well, in the first term, the h's will cancel, leaving us 2x. And h will go into h squared, leaving us with 1h. And then, of course, we will cancel the h's out here, leaving us the plus 4. So when all is said and done, the difference quotient for the function x squared plus 4x minus 7, that simplifies down to 2x plus h plus 4. That would be the difference quotient. Eventually, we're going to examine what happens as h approaches 0. Now think about what's happening in this graph here if h is indeed approaching 0. If h is approaching 0, that means that this horizontal distance is disappearing. So what would cause that to happen? What would cause the horizontal distance to disappear? In order for that to disappear, this point here at the top would have to move along the graph and converge to this point here. In other words, when the top point touches the bottom point, h would be going to 0. So keep that in mind as we progress through the next problem. In our next problem, we have f of x is equal to 5 divided by x minus 4. And one thing we want to keep in mind here is what's going on in the denominator. Because if you'll recall from algebra, we cannot divide by 0. Division by 0 is undefined. In other words, x cannot equal 0, because if x is equal to 0, that would give us, x cannot be 4. Because if x is equal to 4, then we would have 4 minus 4, which is 0 in the denominator. So we have to keep that in mind as we progress through calculus. We have to look out for potential downfalls and what to do about that. So just like the first problem, all we're doing here is we're looking for the difference quotient for the function 5 divided by x minus 4. The first thing we do in order to find the difference quotient is we figure out what is f of x plus h. So what they did was they rewrote the function, and in place of x here, they just substituted in x plus h. And of course, they have the minus 4 because that's in the original function. And in this step here, they just cleared out the parentheses, and that gave us 5 divided by x plus h minus 4. So that would be f of x plus h. The second thing we have to do to find the difference quotient is we have to subtract f of x. Well, again, f of x for this problem is 5 divided by x minus 4. And we have to put that all over h. So here we have f of x plus h minus f of x divided by h. As I said earlier, the hardest part about solving these problems is the algebra. The calculus is typically not the problem. The villain here tends to be the algebra that it takes to simplify these down. So what do you do when you have two denominators that are not alike? Well, if you're trying to add or subtract two fractions with unlike denominators, you have to get a common denominator. So what they chose to do here is they chose to multiply each of these terms by x plus h minus 4 times x minus 4, which happens to be the denominators. And when you simplify that, you end up at this step here. And if you do the algebra simplification, you can put all of this in one fraction. And again, I emphasize here, the hardest part of calculus is the algebra. If we keep simplifying, we end up reducing this down to -5 all over x plus h minus 4 times x minus 4. And again, keep in mind that at some point we're going to evaluate what happens as h approaches 0. If we were to let h approach 0, we could just substitute in 0 for h here, and that would leave us -5 divided by x minus 4 to the power of 2. Now, the difference quotient is the algebraic way of trying to figure out the derivative. Well, fortunately for us, there are some basic derivative rules that will eliminate all of that complicated algebra. So I'm going to talk about the rules, and then we're going to look at some examples and some videos to help clarify what these rules actually mean. The first rule is the constant rule. And the constant rule says that the derivative of any constant is 0. So think about what the term constant means. Constant means that the graph is neither rising nor falling. It's moving in a horizontal line. So let's say in this case, this would be the graph of the horizontal line, y is equal to 3. If you look at it, of course, this is imperfectly drawn because of my limitations here with the technology. But if this is the line y is equal to 3 and it's horizontal, it has a slope of 0. So that's why the derivative of any constant, which is just graphed as a horizontal line, would be 0. So the derivative of a constant is 0. The second rule, the constant multiple rule, says that if you want to take the derivative of a constant times a function, then you can take the constant to the outside and then multiply that by the derivative. And we'll look at some examples of that throughout this lecture. The power rule is actually a favorite of mine. The power rule says that if you want to take the derivative with respect to x of x to the power of n, that is going to be n times x to the power of n minus 1. Let's look at an example of that. Suppose you have y is equal to x to the power of 7. Since we have x raised to some power, we can use the power rule to find the derivative. And all we do is we take the exponent n let me erase that here. If I want to find the derivative, and by the way, this is the shorthand notation for derivative, I could have written d divided by dx, or d over dx. That's also a notation for derivative, but I tend to use y prime. It's just a little simpler. And according to the power rule, I just take the exponent down. This is my n, 7. Multiply that by x to the power of n minus 1. That comes straight from the formula here. And since n is 7, 7 minus 1 is 6. So the derivative of x to the power of 7 is 7 times x to the power of 6. That is the power rule. Next, we have the sum and difference rules, and I'll talk about those together. If you are taking a derivative of a sum, the derivative of a sum is the sum of the derivatives. Likewise, if you take the derivative of a difference, it's just a difference in the derivatives. So I'll show you a quick example here. Suppose you have two functions. Suppose that y is equal to, and we'll just go back and we'll use, let's let f of x be x to the power of 7 again. And let's add to that our g of x, and we'll make g of x 2x to the power of 3. And we want to find the derivative here for y. So my d over dx, or y prime, the derivative of f of x, which is f prime of x, is just going to be 7x to the power of 6. And we got that using the power rule. What about 2x to the power of 3? Well, 2x to the power of 3 will require us to use the constant multiple rule. And what does the constant multiple rule say? Well, the constant multiple rule says that we would just take the constant to the outside. So I'll just put the 2 here. And then I will multiply the 2 times the derivative of my function, which is x cubed. Well, if I use the power rule on x cubed, that means that I have to bring the 3 down to the front, multiplied by x, and raise that to the power of 3 minus 1, which is 2. And if we simplify this, that gives us 7x to the power of 6. plus, I'm going to multiply 2 times 3. That's going to give me 6x squared. So the derivative of y in this case is 7x to the power of 6 plus 6x squared. Next, we have the product rule. The product rule says that if you're looking for the derivative of two functions multiplied together, f of x times g of x, in order to find the derivative, you take the first function times the derivative of the second function, and then you add to that the second function times the derivative of the first. So let's look at an example here. Suppose I have y is equal to, I'm going to keep these very simple since it's difficult to write with this mouse, but we will look at some videos. Let's let the first function f of x be 3x. And let's let the second function be x to the power of 2. Of course, there's a much easier way to do this. If I were taking a test, I would multiply the 3x times the x squared, which would give me 3x cubed, and I would go from there. But since we're trying to illustrate the product rule, we will do that instead, just to illustrate the point. So the derivative of two functions multiplied together, if you go back and look at the formula, it says you multiply the first function, in this case, it's 3x, multiply that function times the derivative of the second function, and the second function is x squared, and the derivative of x squared using the power rule is going to be 2x to the power of 1. How did I get 1 for that power? Well, if you go back to the power rule says that you subtract 1 from the exponent, and 2 minus 1 is 1. So that takes care of the first part. And then we have to add to that the second function, which is x squared, times the derivative of the first. Well, the derivative of the first one, let's see, we know we have an exponent of 1 here. So I would bring the 1 down and multiply that by 3. So that would give me 3x to the power of 0. And everything to the power of 0 is just 1. So we have a 3 here. Now 3 times 2 is 6, and x times x is x squared. So that gives us 6x squared here. Plus 3x squared. Which is equal to 9x squared. Okay, so the derivative would be 9x squared. Let's do that using a much shorter method. Like I said before, if I were taking a test, I would not do the product rule in this case. So let's go back and look at this. I had originally y is equal to 3x squared multiplied by, I'm sorry, this is 3x to the power of 1 multiplied by x squared. The first thing I would do is I would simplify y. I would just change this to 3x to the power of 3. Multiply these two together. So that's going to be 3x to the power of 3. I got 3 because when you multiply, you add your exponents together, and 1 plus 2 is 3. And then I would just simply use the constant multiple rule, and I would multiply 3 times 3. In other words, I would bring the exponent down. 3 times 3 would give you 9. And the power rule says that I would write the x, and then I would have a power of 3 minus 1, which is 2. Notice that we get the exact same answer here. Next, let's look at the quotient rule. The quotient rule says that if you are taking the derivative of one function over another, what you do is you take the bottom function, which is g of x, multiply the bottom function by the derivative of the top function, subtract the top function times the derivative of the bottom function, and then you have to divide by the bottom function squared. And if that sounds like a lot of algebra, it usually is. But for the sake of argument, we're going to look at a simplified version of that. So let's go and look at a quotient here. Suppose I have a fraction and the numerator is x squared plus x. And we will make the denominator 3x squared. And we want to find the derivative. Well, let's do the first part here. We have to take the bottom function, which is our g of x. That is going to be 3x squared. And we have to multiply that by the derivative of the top function. And all I'm going to do now is just use the power rule for each term in the numerator. So that's going to give me 2x plus 1. So how did we get 1? It's not a bad thing to remember that the derivative of x is always 1. Geometrically, because if you graph the line y is equal to x, let's say you graph the line y is equal to x, it would look something like this. And it has a slope of 1. Or you could use the power rule. If you have x to the power of 1, and you take the derivative, you would bring the 1 down to the front, you would keep the x, and then you would subtract 1 from the exponent, and 1 minus 1 would give you 0. And remember, any x value to the power of 0 is 1, and 1 times 1 is 1. So the derivative of x is 1. Now, we're not finished in the numerator because the formula for the quotient rule says we have to subtract the top function times the derivative of the bottom function. Well, the top function is x squared plus x. We have to multiply that by the derivative of the bottom function. And if you take 3x squared and do the constant multiple rule, that's going to give you 2 times 3, which is 6x to the power of 1. So that's just going to be 6x. And students typically forget the next part. We cannot forget that the formula demands that we divide by the bottom function to the power of 2. Our bottom function is 3x squared, so we would have to take 3x squared and square that. I'm going to pause here because I have actually done all of the calculus here. The challenge is going to be the algebra needed to simplify this down. But I wanted to show you the basics of the quotient rule. And let me change colors here and we'll go over it again very quickly. The quotient rule says that in this case, we have to take our bottom function times the derivative of the top function minus the top function times the derivative of the bottom function. And then we always divide by the bottom function to the power of 2. And lastly, we have what is known as the chain rule. The chain rule is used for composite functions. In other words, we have a function inside of a function. And I'm going to illustrate that with, let's say we have y is equal to x squared plus 1. And let's raise that to the power of 3. Well, this problem here is very different. If we had had y is equal to x to the power of 3, we would simply use the power rule. But here we have something totally different. We actually have a function which is x squared plus 1 raised to a power. The power rule says that we have to have x to some power, not a function to a power. When we have a function to a power, we have to use the chain rule. The chain rule says that we take the derivative of f at g of x and multiply that by g prime of x. So let's take a look at that. If I take the derivative of this, I'm going to say 3, which is the exponent, multiply that by x squared plus 1, and then raise that to the power of 2. I got that from subtracting 1 from the 3. So that looks a lot like the power rule, but we're not done, because if you go back to the chain rule, it says that after we finish taking the derivative with regard to g of x, we have to go back and actually take the derivative of g of x, which is the interior function. In this case, our interior function is x squared plus 1. So let's go back now and do the second part. Let's figure out what g prime of x is. Well, g prime of x is going to be the derivative of x squared plus 1. Well, the derivative of x squared plus 1, if we use the power rule, is 2x. Because remember, the derivative of 1 is 0. The derivative of a constant is always 0 according to the constant rule. And I would multiply the 3 times the 2x. That would give me 6x. Times x squared plus 1 to the power of 2. Now we could simplify this further by squaring x squared plus 1 and clearing out the parentheses, but I will stop here and make the claim that we have found the derivative using the chain rule. So what would be the f of x and the g of x in this problem? Well, the overall function is x squared plus 1 raised to the power of 3. The interior function, this is going to be g of x, but the overall function is the f of x. In other words, I have a function inside of a function. And the chain rule simply says, first you employ your power rule, which is going to be your f prime of g of x, and then you have to multiply by the derivative of g of x. Okay, so let's look at a couple of videos here. Remember, the constant rule says that the derivative of a constant is 0. And again, this is because a constant function is a horizontal line, and the slope of a horizontal line is 0.
Derivative of a constant, think of this as an equation. Like if this is y equals 2, when you look at the line y equals 2, we're looking at a horizontal line, okay, like that. And when you think about a derivative, what a derivative really is it's an equation, or it's a formula, okay, for finding the slope, okay, of the tangent line to the graph at any point along the graph. Well, what you'll notice from your previous math classes is that when you have a horizontal line, what's the slope of the graph always? It's always 0, right? So when you take the derivative of a constant, it's going to be 0 because the slope anywhere along this line of this graph, it's going to be 0. So that's why we say the derivative of a constant is 0. Now you could write this out a little bit more formally. You could say dy dx. So for example, if you start off with y equals 2, dy dx.
I intended to show this video having some technical difficulties here, so I'm going to upload these notes into the news feed. But if you go through the notes, click on derivative of a constant, and there is a video where a gentleman explains again why the derivative of a constant is 0. So let's take another look at the power rule. Here we have the derivative of x to the power of 8. And using the power rule, we will take the exponent down, keep the x, and our exponent becomes 8 minus 1, which is 7. So the derivative of x to the power of 8 would be 8x to the power of 7. On the second problem here, we have x to the power of negative 5, looking for the derivative. And again, using the power rule, we would take the negative 5 down to the front, multiply that by x to the power of negative 6, because if you subtract 1 from negative 5, you get negative 6. And then they just simplified. So let's take a look at that. We have negative 5 times x to the power of negative 6 and to simplify that, we keep the negative 5 in the numerator, but we take the x to the power of negative 6 to the denominator and make that x to the power of positive 6. Remember, the exponent rules say that if you have a negative exponent in the numerator, you may take that term to the denominator and make it positive. And the last example, we have the derivative of the square root of x. Well, remember that the square root of x is also x to the power of 1/2. And since we have a power, x raised to a power, in order to find the derivative, we can just use the power rule, which is what they did. To use the power rule, I'm going to bring the exponent down, multiply that by x to the power of 1/2 minus 1. Have to subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. And again, we do not want negative exponent in the numerator here, so we will take the x to the power of negative 1/2. We will take that to the bottom and make it x to the power of 1/2. And since they gave us the problem using square roots, we will give the answer back using square roots. So we will just transform that to 1 divided by 2. And in place of x to the power of 1/2, we will simply do the square root of x. So let's talk about how far do you simplify. Typically, we do not want negative exponents, which means we usually have to slide those from the numerator to the denominator or vice versa in order to clear out negative exponents. And we typically do not like, we typically like to give the answer back just as it's written. So since they have square roots in the problem, we typically like to give square roots back. If I were teaching this, if I were taking a test and I were to put this down as the answer, that would be technically correct. But some professors are very sticky about how you actually write your final answer. Probably not going to be an issue for my math lab. Just keep that in mind in case you run into some difficulties. Sometimes the hardest part about my math lab is it's very picky about its rules. So if it tells you to round, let's say, to the nearest whole number, make sure you do that. If it asks you to round to the nearest tenth, make sure your answer has 1 decimal place, not 2. A lot of times students will ask me to work a problem in my math lab, and I will work it and get the exact same answer the student got, and my math lab will tell me that it's incorrect. And after several minutes of frustration, I finally go back and read the problem. And most of the time I did not follow directions. It will ask me to round, let's say, to 3 decimal places, and I chose to round to 2 decimal places. Well, it will mark it wrong. You just pay attention to the directions, and usually things will go fine. Otherwise, you will have lots of frustration in my math lab. Again, there will be posted another video here for the power rule, and there will be a video posted for the sum and difference rules. And just for fun, let's look at the derivative of this function here. And since this is a sum and a difference of terms, we will actually combine the sum and difference rules here. And the derivative of f of x, we have seen several ways so far to write the derivative. We could do d over dx. You all have seen me use y prime. Another way to write the derivative could be f prime of x. You will also see that from time to time. So let's take the derivative of the function. Looking at x cubed using the power rule, I'm just going to say that the derivative of that term is 3x squared. Then I have to subtract the derivative of 4x. The derivative of 4x is going to be 4 using the power rule. And then, of course, the derivative of a constant is 0. So the derivative of x cubed minus 4x plus 5 is actually 3x squared minus 4. So we took the derivative of a cubic and we ended up getting a quadratic. So here again, we have a product. We have 2 functions multiplied together. So in order to find the derivative of this one, we would have to use the product rule. And remember what the product rule says. The product rule says that we take the first function, which is x to the power of 4, multiply that by the derivative of the second function, plus the second function times the derivative of the first. Now, if we were doing this lecture in class, I would probably not write this step, and it's definitely not required, because after you get a lot of practice at taking derivatives, you typically know to just go to this step here. This is the first function. This is the derivative of the second function, plus the second function times the derivative of the first. And of course, the derivative of x to the power of 4 is 4x cubed. And the rest of this, again, is just algebra. In the final analysis here, the derivative would be 7x to the power of 6 plus 12x to the power of 5 plus 20x to the power of 3. Next, we have an example of the quotient rule again. And remember, the quotient rule says you take the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function. And we always have to divide by the bottom function squared. So here we have a quotient, so we have to use the quotient rule. And using the quotient rule, we have the bottom function. We're going to multiply that by the derivative of the top, subtract from that the top function times the derivative of the bottom. In this particular case, they reversed our order, which is okay. And we have to divide by the denominator squared. Again, if we were doing this in class, you probably would hear me say all of these things, but I would actually be writing this step here. And again, Using algebra, we simplify and we finally get a derivative here. And then again, we have the chain rule, which is reserved for composite functions, which means you have a function raised to a power, for example. And let's go back and look at another example of the chain rule. Now, if this had been y is equal to x squared, if this had been y is equal to x squared, we would simply say that the derivative is 2x. But this is not the case. This is not x to the power of 2. This is actually a function to the power of 2. So we do the power rule in the first step. In other words, we take the exponent down, we multiply it by the function, we raise that to the power of, in this case, 2 minus 1. But since we have a function to a power, remember, we have to multiply that by the derivative of the innermost function, which is 2x squared plus 8. So here we simplified. Here we took the derivative of 2x squared plus 8 using the power rule with the constant rule. That's going to be 2 times 2 is 4x to the power of 1. And if you want to clear out parentheses, you could distribute the 8x across these terms here, which gives you 16x to the power of 3 plus 64x. So this would be the final answer here for the derivative of this function raised to the power of 2. And again, after I upload the videos, you could click here and you could see yet another example of the chain rule. So this concludes our lesson on derivatives. And if this is your first look at derivatives, you may be somewhat overwhelmed, but the key is lots of practice. So here's what I encourage you to do. Go back through the notes, watch the videos that are embedded in the notes, and then I'm also going to post a lot of other video resources from YouTube. Go back and watch those. And then I would encourage you to go into the e-textbook inside My Math Lab and look at the examples there. And then just dive right into the homework. And once you get into the homework, as you should know by now, if you are struggling, there are resources inside the homework problem. So feel free to click on any videos that are available. If you need for them to show you an example, they can do that. But keep working and working and applying these formulas, and you will get better at finding derivatives. Of course, the more complicated the function, the more difficult it can be. But for the most part, we shouldn't find anything more difficult than what we have here. Since this is applied calculus, we're not going to delve into trig functions and things like that. So practice. If you have any concerns, please reach out to me. If you have worked problems in the homework and you have just done everything that you possibly can do to figure it out, if you have if you've looked at the textbook, if you have watched the videos and you have tried and you simply are stuck on a problem, by all means, send me a screenshot and I will get back with you on that. Thank you.